I mean, I'm not enough of a Marxist, for example, to say that just because it's driven by financial prerogatives that it's a bad thing. I don't think it's bad. I just think we need to know why it's what's driving it at this point in time. Another really interesting thing that's driving it, I think, is that it's structurally latent. Ubiquity is structurally latent in so many of the standards and agreements and technologies that we're developing right now. And what do I mean by that? Well, we know how the internet works. The internet works on a network layer protocol called IP, Internet Protocol. The current version of IP is IPv4, and it has a 32-bit address space. And the really interesting thing about a 32-bit address space is that even though it sounds fairly large, we're running out of them. In just the 10 years that we've had the World Wide Web, we have taken up almost all of the real estate of a 32-bit address space. So the number of internet hosts in the world that will ever be available in the IPv4 addressing schema is going nowhere. I mean, the end is clearly in sight. And so, as you know, we have the new version of IPv6. And what the people who framed and developed IPv6 decided was that they're gonna sketch out a 128-bit address space because they don't ever want to run into this problem again. I mean, they don't ever want to deal with running out of room for new hosts. And you know what the thing about 128-bit address space is that that kind of namespace is overkill. It provides 6.5 times 10 to the 23rd addresses, not merely for the world, which would already be quite a bit more than IPv4, but for every square meter on the surface of the planet. And there's almost a teleology in that. There's almost something that wants to become in that. Now, I'm neither a techno-determinist nor a cultural determinist. I think technology and culture influence each other in a very complicated interaction that is continually permutating and evolving. But I will say that when you devise something that allows there to be 6.5 times 10 to the 23 addresses for every square meter on the planet, what that means is that you want to turn everything into a node. You want to turn not merely everything, but every part of everything into a node. Every shoe, every light socket, every trash can, every water bottle, every button on my shirt, every key on the keyboard, everything can have not just an IP address, but multiple IP addresses, and it can communicate with everything else in the world that is networked. And it's not just IPv6. It's other technologies as well. QR codes and RFID tags are light and cheap and easy, and they provide bridges between the physical world and the virtual world. They are so light and cheap and easy that it doesn't make any sense not to put them in places where there might someday be a potential possibility of utility. So you slap a QR code up, or whatever comes next, whatever version of that optical recognition system comes after QR. I certainly hope something does, because personally I think QR is extremely ugly. RFID, the same thing. You know, it costs about 50 American cents per tag right now, but you know, they've been talking for years that the price is dropping. And the authorities are agreed that when the price gets to about 5 American cents per RFID tag, that there's going to be no reason not to put them everywhere. So we have IPv6, we have RFID, we have ultra-wideband and WiMAX. We have these wireless networking standards, which again allow for the possibility of mobile, ad hoc, mesh networks of devices that continually establish new connections that rebroadcast connections to the other devices around us. And what all of these technologies have in common is this sense of momentum, is this sense of teleology, is this sense of pulling towards something. And what I argue that they're all pulling towards is what I've called everywhere, is a world where every single gesture of a life is recorded by something, and probably many somethings, and is picked up and renegotiated and retransmitted, and is part of the global mnemotechnical system, the planet's memory, forever after. So this is another reason. This is something else that's driving it. And we should not forget, especially for those of us who are engineers, developers, designers, or the people who are actually crafting these technologies, that this is technically sweet. Now, these are words that were used by J. Robert Oppenheimer, the American physicist, when asked why he would lend his prestige and his effort to developing the atomic bomb. I mean, he was known to be an individual of conscience and ethics, and people said to him, "Why would you do something like that? Why would you design a device of such incredible destructive power and such horrendous effect? And he said he was at a loss for words, and then he sort of reached for this idea, and he said it was a technically sweet challenge. It was intellectually provocative to me as an engineer. And I think this is something that we need to accept about ourselves as monkeys, ourselves as tool-using monkeys, that we cannot resist a challenge. Even when somebody like Oppenheimer knows perfectly well what addressing that challenge might lead to, the kind of suffering that might wait beyond its resolution. We cannot help but tinkering at it. And to me, this is personally relevant because I am sick to death of websites. I've developed websites for a very long time. I haven't been in the web industry during the entire length of the web industry, but I've been there for about 70% of it. And I am exhausted. If I never go to another meeting where my client asks me to help them develop a website again, I could not possibly be happier. It is a resolved challenge to me. I personally think a trained SEAL could design a website at this point in time. So there is a sense in which the very deep problems of ubiquity, the very deep problems posed by Everywhere, are a irresistibly tasty challenge to me. It is technically sweet. It's something that, yeah, I mean, I could spend the rest of my career very profitably and very productively investigating this domain that we're discussing today, because the problems are so deep that they're never going to go away. Let me say this out loud. It is fun. It is really fun to have these very deep challenges and to address them intellectually. It is much more interesting than a client insisting that you stay in the office until 4 o'clock in the morning developing a logo which they're going to pay you about 700 yen for, which they're never going to use. Right? So this sort of challenge for developers, very hard to resist. And finally, there's something which is the other part of the very common duo of justifications for Everywhere. The first is convenience. The second is public safety. The second is security. Ever since September 11th, 2001 in the United States, there has been a political sense that what we must accomplish with our technologies is to reduce the public sphere, restrict people's free access to the public, and limit unmonitored activity. That it is a political prerogative that we do this, and that we should and are wisely advised to suspend our sense of civil liberty in the name of collective security. I do not happen to agree with this viewpoint, but it is extremely pervasive, it's extremely emotionally convincing, and it has been re-inscribed with every incident of war and terror that has happened since, from Bali to Madrid to London. And this is a city that also understands particularly well what happens when people do evil in public space. So this is also a place where this is a very persuasive argument, where the idea is that if you monitor people in the subways, and when you monitor people in the airports, and when you monitor people on the street, you have a much better chance of preventing terror. We call this security pantomime. We call it security theater. And there are those of us who are very cynical and very sarcastic about this and don't really think it accomplishes very much. But there cannot possibly be any doubt that this is a prime funding source for a lot of the research into ubiquity that happens, certainly in the United States of America, where it comes directly from the Pentagon and for the Pentagon's research into security. What I mean to say by all of this, and you will have understood by now probably from the comments that I make and the way that I make them, that I'm not 100% optimistic about our future. But I don't ever want to leave people thinking that there's no hope. And I don't ever want to leave people thinking that this technology is inherently bad and we can't do anything with it except for prepare to suffer the consequences. I think that although the odds against it are very strong, I think that we really do, because the stakes are so high, have some chance of developing a culture of technological development that is wiser than any that we've ever seen before, that is just a quantum level higher in terms of the ability of skill and empathy that it brings to the task of technological creation. Now, we may be right to be cynical, but I think that we can, we should, and in fact we must aspire to this. And for that reason, I wish to spend the last few minutes of my talk now discussing how we can go about designing ubiquitous systems in a way that makes sense to us as human beings.